In this video, we want to find the integral from 0 to square root of 3 of the inverse tangent of x dx. So first, let's just solve for the integral without the limits here. And for that, we're going to use integration by parts. Because we don't know the integral of inverse tangent of x, that's going to be our u. And we know how to take the derivative of that, which is 1 over 1 plus x squared dx. And the antiderivative of 1 dx is just x. Now we're going to do u times v minus integral v du. So that's x times inverse tangent of x minus the integral of x over 1 plus x squared. Now we have to figure out what the integral of x over 1 plus x squared is. So we're going to make a u substitution. We're going to let u equal 1 plus x squared. So du is just 2x dx. Notice the denominator is going to be u, and then x dx is du over 2. And I'm going to factor out the 2 outside. So we have 1/2 du over u. The antiderivative 1 over u is ln of u. And u here is 1 plus x squared. So now we can put it all together. The integral of inverse tangent of x is x times inverse tangent of x minus 1/2 times ln of 1 plus x squared. Okay, now let's go back to the original question. What is the integral from 0 to square root of 3? Well, we find the antiderivative, which is above here, plug in square root of 3. And if I plug in 0, I get 0 because you'll end up 0 times anything is 0. And then here, ln of 1 is 0. So I don't care about 0. That's going to be 0. So inverse tangent of square root of 3 is just pi over 3. 1 plus the square root of 3 squared is just 4. And now I can use some algebra to simplify this. I can rewrite 4 as 2 squared. And notice I went from absolute value to parentheses. That is because whatever is inside is positive. So if it's positive, you no longer need the absolute values. Now this 2 will come outside, and it's going to multiply the 1/2. So those are going to cancel, and I'm left with pi times the square root of 3 over 3 minus ln of 2 as my final answer.